Hi guys, it's Mrs. Renfro again. This time we are looking at page 5, which is Understanding Rate Concepts. So rate, if we remember, is usually like miles per hour, so many words per minute, typing, things like that. So we're going to be finding those answers in these problems. Number 1 says it takes Maya 30 minutes to solve 5 logic puzzles, and it takes Amy 28 minutes to solve 4 logic puzzles. Use models to show the rate at which each student solves the puzzles in minutes per puzzle. So Maya is 30 minutes for 5. Amy is 28 minutes for 4. So what I did to solve this is I just wrote out the rate first, or the ratio first. So Maya is 30 minutes for 5 puzzles, which if you figure out the rate for that, you're going to do 30 divided by 5, which gets you a rate of 6. Let me erase that and put that underneath there, which gives you a rate of 6 puzzles per minute. And it says Amy has a rate of 28 minutes for 4. And if you do 28 divided by 4, that gets you a rate of 7 puzzles per minute. Or I'm sorry, 7 minutes per puzzle. So these are backwards. Sorry about that. 7 minutes per puzzle. And this one is 6 minutes per puzzle. Okay, so we figured that out. And then the next question says, if Maya and Amy had the same number of puzzles to solve, who would finish first? Well, if you look at this, it takes Maya 6 minutes to do a puzzle, while it takes Amy 7 minutes to do a puzzle. So the one that's going to finish first is going to be Maya. And to explain that, we would say it takes her 1 minute less than Amy to do a puzzle. Okay. All right, number 2, a garden hose supplies 36 gallons of water in 3 minutes. Use a table of equivalent ratios to show the garden hose's water flow in gallons per minute and minutes per gallon. I thought this question was kind of strange. Usually you wouldn't do how many minutes it would take for 1 gallon. It's kind of backwards, I think. But nonetheless, we'll do the problem. So 36 gallons of water in 3 minutes. So we're going to write that first. 36 in 3. And what I did is I just put gallons and then minutes. And then I made a little chart here for 2 minutes and then 1 minute. And if you divide 36 by 3, let's do that off to the side. 36 divided by 3 would be 12, right? So we know 1 minute is going to be 12 gallons. And then 2 minutes is double that. So that's 24 gallons. And that's all that I did on that one. And then they want us to flip it around and find out minutes per gallon. So we've got 12 gallons in 1 minute. We want to find out how many minutes it takes for 1 gallon. So for that, you have to do the 12 gallons, 1 divided by the 12 gallons, which gets you 0.08 minutes for 1 gallon. And you can continue the chart out for 2 gallons and 3 gallons. Just double this, which is 0.16 minutes. And then for 3, you have 0.24 minutes. Then the question on the bottom says, how many gallons of water does the hose supply in 10 minutes? So I would use this chart right here for that. So we're using the 12 gallons in 1 minute, and we want to find out how much it would be for 10 minutes. So to find that, you're just going to take 12 times 10, and you get 120 gallons. And the explanation is there in the work, that if it is 12 gallons for each minute, 10 minutes would be times 12, and you'd get 120. Okay, on the back side of this page is the third question for this lesson. I don't know how I've got that line up there. I need to erase that. Okay, so for number 3, Max travels to see his brother's family by car. He drives 216 miles in 4 hours. What is his rate in miles per hour? And then they want you to use a double number line to show your work, which is probably going to confuse some people. What I did first is I wrote the 216 miles in 4 hours. Now, to find out how much that is per hour, you're just going to divide this. 216 divided by 4 is 54. So that's the first part of your answer, 54 miles per hour. Now, they're wanting you to use a double number line to show that. So on the top, I'm going to have miles. Start here with 0. And we're going to end at 216. So to match that up, we have 0 here for hours, and over here we have 4 hours, because we know we did 216, and that looks like a bigger number. I apologize for that. 216. There we go. In 4 hours. So what we're going to do is figure out for 1, 2, 3, and 4. And that's not very evenly spaced. Kind of want to fix that. So this is 1, 2, 3, and 4 hours. So then we have to figure out in 3 hours, 2 hours, and then 1 hour we already figured out was 54 miles, right? So for 2, you're just going to double the 54, which is 108. For 3, you could either add 54 to the 108 or subtract 54 from the 216, and that one is 162. So there you've got your double number line showing how many miles for each of those. Now the last question says, suppose he makes 2 stops of 10 minutes each during his journey. Will he be able to reach the town in 4 hours if he keeps the same speed? Okay, so he's making a 20-minute stop where he's not driving total. It takes him 4 hours, going 54 miles per hour to get the 216 miles. So no, he can't do that unless he increases his speed or just adds 20 minutes to his time. So it would be 4 hours and 20 minutes to get the same distance. But no, he cannot do that at the same speed because it takes all of the 4 hours to go the 216 miles. So no. And like I said, he would either need to increase his speed or add 20 minutes to his total time and be 20 minutes late. Okay, that's it for today. Tomorrow we will do using unit rates to find equivalent ratios, which is page 7. So if you want to work on that one, it's 7 and 8. There are 11 problems on that one. So page 7 and 8, if you do that one, you'll be ready to come back and watch the 4th video.